Hello, everyone. Welcome to our Chronosphere product demo. My name is Scott Kelly, and I'm a senior product marketing manager here at Chronosphere. And I'm joined by John Potokny, one of our principal solutions engineers. Today, we'll be showing you an inside look at the Chronosphere platform, specifically the control plane. But before we begin, we'll be doing a fun giveaway as part of this demo. If you can correctly identify how many times we say the word control throughout this demo, which will probably be a lot, we'll send you your very own Control Freak kit. So what's a Control Freak kit? It's a Control Freak t-shirt, some socks, and a $100 Amazon gift card. And there'll be 5 lucky winners for those who qualify. So be sure to listen carefully. So let's get started. So John, today we're going to be focusing on our control plane for metrics. Can you tell us why a control plane is necessary now? Like, how do we get here, right? Like, what's changed? Is it cloud native? Is it Kubernetes? Is it microservices? Is it all of the above?
Yeah, it's all the above and probably even more, Scott. The architectural shifts that organizations have been making over the past several years, adoption of microservices, containerization of applications, and orchestrating those containers on platforms like Kubernetes, all contributes to having a lot more components in their systems that they have to monitor and collect telemetry from. And as a consequence of those architectural changes, you're also making a lot more changes to the system itself. More teams organized around more services are doing more changes that can potentially introduce additional telemetry and additional cost. So each container that we monitor today can have as much telemetry that it's emitting, as much metrics that we're capturing about it, as applications running on VMs used to prior. And when you combine that with potentially many deploys happening in a given day for the various applications that we're developing, there's a lot of opportunities for developers to introduce changes, new metrics, or additional dimensions for metrics that can cause a cardinality explosion and significantly increase the cost of metrics. So having detailed visibility and control over the raw data that we're collecting from our systems becomes incredibly important. Otherwise, you end up with runaway observability costs.
So you mentioned cardinality. Cardinality is a really important concept here, right? This is something that is one of the big changes that happens. Can you talk a little bit more about that, just to explain what that is for everybody?
Yeah. So if you're not familiar with cardinality, what we're referring to is how many unique permutations there are for all the dimensions on a metric. So for a simple example, if I'm looking at a metric that's capturing how many requests per second a given application endpoint is handling, there's probably different things that I want to understand, like how many requests return a 200 status code versus a 500 status code. Having a dimension to break down status codes is going to give me different permutations of the same request count, one for 200s, one for 500s, and so on. We can add additional dimensions to it, like what version of the application is running, or what is the name of the application instance, right? The name of the container or the pod that is handling the request. All of these dimensions combine together, and you end up with more and more unique combinations that you're keeping track of the same request count for. The more you have, the more data that there is that you're capturing, and the more it ultimately costs to store and analyze. So we want to be very deliberate about the cardinality of our metrics to make sure that we are striking the right balance between visibility into our systems and the cost of being able to capture that metric data.
Excellent. And that's kind of the genesis of Chronosphere, right? So if we go to the next slide,
Yeah.
just to give a brief overview. So our founders came out of Uber, and they had a really high cardinality metric issue that they were trying to deal with, and they ended up building a system that could handle that. And then after it was M3DB was the database, and and then Uber open sourced it, and then our founders actually left to start Chronosphere, figuring out other companies going to have that problem. And so just to give you an overview, Chronosphere is a single tenant SaaS observability platform, and we really take a differentiated approach to controlling data volumes and helping developers solve problems faster. It's purpose built for cloud native architectures, like I said. It's 100% open source compatible, so you have no vendor lock-in. It's very scalable, reliable, and performant. As I said, we learned how to do this industrial high performance and high availability storage from building M3 at Uber. We have the highest uptime SLA in the industry at 99.9%, and historically we've delivered 99.99%. And as I said, the control plane at the center is really what we're here to talk about today, and that's one of our differentiators. And this really ensures that you can control the cost of observability data and align it to the value that it's actually delivering. Our control plane is actually built around a framework we call the observability data optimization cycle, or OLIDOC, we refer to in short. And you'll actually receive a link to a blog post after this that will give you more detailed information. So if you move on to the next slide.
Mhm.
And so this is kind of the framework, and this is how our control plane is the tooling that we have is focused around this. So it starts with centralized governance, which is really about setting guardrails, giving teams quotas, making sure that they understand the value of their data, and also the ability to contain cardinality spikes that we just talked about, and prevent overages to control costs. And then the next phase, once that's set, right, you can move on to the next phase of analyze. And analyze is really about, you need to understand the value of your data in your system, right? There's a lot of data, as John talked about, a lot of tags. It's easy for developers to add tags, and they can have a really big consequence on your costs and also the performance. You need to know how it's being used, if it's being used, where it's being used. And then once you have that information, you can then go into the refine area. And that's really about setting shaping policies to optimize the data, using aggregations and things like that, and being able to drop data, because now that you understand the value of that data from the analyze phase, you can make those changes and you can transform this data to make sure that it actually is delivering the value that is required. And then lastly, as in any cycle, because cloud-native environments are highly dynamic and changing all the time, you really need to have keen insights into how all these things that you've been doing are actually working, and you need ways to understand how optimal they are, right? So we give you tooling to help you do that, and to understand how your shaping policies are performing and such. And so those are the things we'll be talking about today. And so if you go into the next slide here, give you a quick view to align some of the features to that framework. So for centralized governments, we'll be showing you our quotas feature that helps to protect against cardinality spikes and budget overruns. From the analyze phase, we'll be showing you the live metrics analyzer. This helps you identify high cardinality metrics in real time as one of its key use cases. Also, our metrics usage analyzer that helps you understand the actual cost versus the utility of every metric or label in your system. And once you understand that, we have a really robust set of shaping rules, drop rules, aggregations, things like that, to help you optimize your metrics, to control costs, and help you improve performance. And then lastly, we're showing you usage metrics to help you understand how workload costs change over time. So John, let's jump on into the demo.
Yeah, sounds good. I'll shift over here to Chronosphere. And we can get started. So walking through the platform, as you mentioned, Scott, let's start off by talking about how you can set up guardrails and have centralized governance using quotas. So if I go into the Metrics Quotas section in the platform, we can see I've got a few different quotas set up in my demo environment here, reminiscent of being able to break up the capacity that I'm using for my metrics across different teams within my organization. So I've got a handful of different pools. They're taking the overall 50,000 data points per second capacity that I have allocated here and giving chunks of it to each individual team. You can see ordering team, payment team, fulfillment team, as well as some default capacity for anything that doesn't fall into ownership of one of those teams. So dedicated groups that I'm calling out, and then kind of one catch-all for everything else that's kind of on the periphery that I haven't specifically allocated quota to. And I can dive into the utilization for any one of these individual pools to understand, how it's behaving versus what I've allocated to it, as well as see a summary across, all the different teams. We can see right now my ordering team and my default groups are over their quotas, whereas the rest of them are all very healthily within the allocation that they've been given.
So if they're over their quota, what happens to that data? Does it just get dropped, or how does that work?
Yeah, great question. So the way that this works is actually pretty interesting. Right now in my system, nothing is getting impacted, even though my ordering team, for example, is over its quota. And the reason why is because there's capacity available within the system as a whole. You can see across all of my pools that I have defined, I'm only using about 22% of that 50,000 data points per second capacity that we're carving up here. So even though the ordering team is using 132% of its dedicated capacity, there's room in the system so that the data that's sending over its allocation can be persisted without any issue. If we were at 100% utilization for the entire system, then we would look at which teams, which pools are over their quota, and then start to rate limit the traffic that's going into those pools specifically. So if my payment team is still under their quota, but the ordering team is over theirs, only the ordering team is going to get impacted if the system hits its capacity limit. So you can think of quotas as guaranteeing traffic up to a point, but it's not a hard limit on its own unless the system itself is hitting its capacity limits that's been defined. And when that does
And
happen, sorry, is there a question?
no, go ahead. I was going to ask. So once how are they? You can set alerts against these, right? So like people would know as if something's an instant overage, that's obviously due to something that occurred. There was a change in something, but also over time you can be alerted to changes in this, correct?
Yeah, absolutely. All of the data that you're looking at here, these are actually based on metrics that we emit into the platform that you can use just like any other Prometheus metric. So defining an alert to let me know when teams are over their quota that's been configured, as well as when teams are starting to have those quotas enforced because they are over and the system as a whole is at its limits. So both of those things are possible to alert on, or if you just want to know if there's any significant change in your utilization, of course. One other thing I'll note here is that when you are in a situation where quotas have to be enforced for a given team, teams have the ability to go and prioritize, delineate the traffic that they're sending in for a given pool, so that you can say what's high priority versus what's not as high priority, medium, or low. You can see here, for example, I'm using the environment dimension for my metrics to delineate high versus low priority. My production environment is high priority. My staging environment is low priority. I'm not as interested in that traffic, relatively speaking. So if the ordering team did start getting limited because of it being over its quota, the data for the staging environment would get dropped before data for production. So you have the ability to go and determine not just how much capacity different pools can use, but also how enforcement against those pools is actually done when they start to go over their defined quotas and the system needs to shed load. So pretty flexible guardrails in place here to help us understand how the system is going to behave, as well as the ability to go and break up your workload into whatever logical grouping makes the most sense for your organization. It doesn't have to be a team or application. It can be whatever dimension you want to use. So you're able to understand how your workload is changing over time, make sure that teams know where they're supposed to be standing, and give them the ability to control what happens if they start to go outside of those boundaries.
And this is setting the stage for teams to actually understand the value of their data, right? Because now they have to think about what's that data the data that I'm collecting, developers that they're adding tag, how valuable is this? Is this something that I really need? It's kind of, you're putting the guardrails there, but it's really about making them think about, how they, what they're using and how they're using it. And I think part of this is, quota sounds like a punishment sometimes, but it's actually, it can be used in the reverse to actually make a decision on, having to increase capacity later and using data-driven decision, using data to actually do that. I think we're going to walk through that in a little bit to show you that you could show the analysis and stuff that you can do. But yeah, I think, this is it's good to set these guardrails because it makes people think about the value of their data in the system.
Yeah, you mentioned it before, Scott. The most important, or the first step in the observability data optimization cycle is having centralized governance in place. It's really hard to analyze and make decisions about your workload without having a foundation of understanding about where you would expect things to lie. And so if you try and have teams take a look at and say, what metrics are important? Do you need all this data? They say, of course we need all this data. What's the
Just
problem?
in case, right?
Once you have a baseline of, we're trying to make sure our observability costs are X percentage of our overall budget, and that means that your team has this much room for data. Now let's go take a look and say, hey, what metrics are actually important? Because it turns out you're using way more than you should by all indications based on what our targets are. So yeah, as you noted, Scott, you can define alerts based on these quotas as well. So kind of one of the typical use cases here is I'll set up an alert to let individual teams know when they're going over their quota or if they start getting data dropped as a result of quota enforcement. And you can have that configured so that not just the central team, but the actual constituent teams are getting notified when that happens. And then those teams can go into the platform and analyze, okay, what is going on with my workload in order to understand, what change was introduced in the system that's causing that increase to happen. So if you have a sudden spike in the amount of utilization for a given pool, for a given team, we can very quickly go and trace that back to its source. And one of the ways that we do that is with the live telemetry analyzer in the platform. I go and look at the metric analyzer in here and just kind of turn it on. It's going to give me a live feed of all the metric data that's coming into the Chronosphere platform. So we're looking at everything that my demo tenant here is receiving. You can see all the dimensions that we're seeing for the data coming in. I can see how many unique values those dimensions have. And of course, over on the right, what the metrics actually look like in terms of data points per second. This is totally flexible. We're seeing the data in real time as it's arriving. So I can break it down any which way that I want, say by application name, or if I want to look at a particular application, particular team or pool, I'm able to do that as well. And in fact, there's quick definitions for me to go and do things like say, hey, I saw my ordering team was over its quota. I want to go and understand what traffic is coming in for the ordering team, so I can get a sense of where utilization is coming from. This is really useful when you do have that situation of a change in the workload has happened. All of a sudden, a given team or given pool is using a lot more capacity than it was previously, or if the system as a whole all of a sudden starts using more capacity than it was previously. You can come into the metric analyzer, and the most expensive sources, the things that are going to be driving those increases, will bubble right to the top. We can see what has the highest cardinality on a per dimension basis, what is the most expensive metric in the system on a per metric basis, or any other dimension you want to break it down by, and use that to very quickly understand, okay, here's what's going on. I've got a dimension that has way higher cardinality than I expected, or a new metric that I've added is a lot more expensive than I anticipated. And when that happens, we can use shaping policies to go in and correct things if necessary. We'll talk about that
So
more.
you don't need to, so the developer doesn't need to redeploy, right? They don't need to call somebody in to either, or you don't have to roll back either, right? That's the shaping policies allow you to do that
Right.
centrally.
Yeah, you've got all the control that you need within the platform to be able to drop a new metric or discard a new dimension, so that you don't have to go and revert a change to an application that might be tied to a larger feature change. It's not uncommon to have observability changes not rolled out in such a phased way where it's easy to roll them back if they're tied to significant feature developments. So not having to do that makes it a lot easier to go in and correct behavior at your leisure in the background, rather than having to do it as a fire drill.
So you're still ingesting, the data is still being sent, right? But
Mhm.
we don't charge for ingest, we only charge for persisted or stored data, right? So that dimension or that metric can still be sent, and we drop it in real time before it's persisted, so that you don't actually have to pay for that.
Yep, absolutely. And in fact, one of the kind of neat things about the metric analyzer here is we actually allow you to go and see different parts of the ingestion pipeline and profile it at any kind of phase. So if you do have a rule in place to drop a metric within the platform, we're able to see that as well. You can go and look at what data is being dropped and not persisted, just as easily as you can look at the data that is coming in and being stored. This actually becomes really useful as well when you want to introduce new metrics in the system, but you're not sure about their cost. So rather than deploying something and having to go and investigate because all of a sudden you have an alert telling you you're over your quota, you can create a drop rule ahead of time to explicitly not persist the metric, go ahead and roll it out, and then take a look at how expensive it's going to be and what the cardinality looks like in production before you make the decision to go and persist it. So developers can use this to be a little bit more careful about the changes that they're making to their observability when they're introducing new metrics. We can preview what it's going to look like in the platform without incurring any cost, and then go and say, okay, this is safe to roll out, or we might need to go and ask for additional capacity for our team in order to make this metric work, or have to change the dimensions that we're capturing for it in order to fit within our established quota.
Excellent.
I know we mentioned shaping a couple times briefly. One thing that's always important to talk about as well when we're talking about making changes to the shape of the data that we're storing is understanding how that data is actually being used in practice. Being able to see that something is expensive is helpful for being able to triage what happened when you see a sudden spike in the cost of your workload. But the other half of the coin is, of course, is the data that we're sending in valuable? And so that's where the metric usage analyzer comes in to the picture. We want to be able to show teams, organizations, how they're using the data that they send to Chronosphere so that they have the ability to, with data, determine, is this something that I should choose to pay to persist? Or is it something that I might want to leverage a shaping rule in order to reduce the cost of, because it turns out it's not as valuable and it's not worth the cost. So looking at the usage analyzer here, I can do just that. You can see right now it's showing me the least valuable metrics in my system. How do we determine value here? We're looking at a few different things. In particular, is a metric being used in any part of the platform? Can we see it being defined in dashboards or alerts or anything else that can reference metrics in the system? So configuration references here tells me the metric I'm looking at doesn't have any references. We also look to see if people are querying it either from configuration references or in an ad hoc fashion. So if I go into my metric explorer and I look for that metric, it'll show up here. Or if I have an API externally from the system that's using it for something, we'll be able to see those queries as well and catalog them. We take these two things and we boil it down to a utility score, which is basically making up how many places is it referenced, how many people are querying the metric, and how often it's being queried. In this case, my least valuable metrics are all metrics that are not being referenced in any dashboards or alerts or anything like that on the platform, and nobody's querying them. We're looking back over 30 days right now. We can say no one's using this metric, but it still has cost. If I'm responsible for this metric in the system or for the overall budget for observability, I might want to go and stop storing this. I don't have to pay for it. And you can do that very easily from the system. I can go ahead and just create a drop rule for some of these metrics to reduce the overall cost that I'm paying. The rules here that you can define are very flexible. You'll see right now, it's just taking the names that I selected for the metrics and putting them into a filter. But I can also qualify them and say, hey, I don't want to drop this data from production just yet because I want to have a chance to make sure that nobody is interested in using these metrics. So I'm going to add another filter. Environment, there we go. And only drop this data for staging first. And so now we have the ability to go and say, hey, we saw that these metrics are unused. We're going to drop them from the system. We're going to do this in staging for a week. And if we don't hear anybody saying that they want to have them still, then we're going to drop them from production as well. Makes it very easy for us to roll things out in a phased fashion, ensure that you have complete confidence that this is low value metrics and not actually something that somebody wanted to use and just hadn't gotten around to adding it to a dashboard or something like that.
And the flip side of this, right, is that if someone does want to use it later on, there's no changes being made by the developer. If they like, hey, I need this metric, you can just come in here and turn it back on, and then they'll start persisting, right? So that's the flip side of this.
Yeah, very, very flexible to go and create these rules. If you want to go and make changes to it more dynamically, you can do that as well. The last thing I'll note is it's really easy for me to go and apply these using config as code as well. So you can see here, automatically generate the Terraform definition for creating a drop rule using our open source Terraform provider. Or if you want to use our REST API, we can generate an API config. You can just go and apply this using that appropriate endpoint. So really easy to go and create and manage these rules in the platform. They are designed in such a way where they can be turned on and off very quickly, and they can be scoped to exactly the set of series that you want to go and filter out. You don't have to worry about accidentally dropping data that was useful or having a long time to go and revert that rule if you need to. Of course, drop rules are just one type of shaping. It's all well and good to be able to identify and remove metrics that are not being used in practice. I think the more interesting use case, though, is probably when we have metrics that are valuable but also expensive. This is where it gets kind of fun, right? Because if I've got a metric that has value, it's being used in dashboards, it's being queried by people, but it is one of the most expensive metrics in my system. That's a case where you start to ask yourself, is it worth the cost? Um, and more often than not, what we find for cases like this is it's not a matter of is the metric valuable or not. It's are all of the labels or all the dimensions on the metric valuable or not? Are there metric dimensions that I could potentially remove? Not the metric itself, but say, one aspect that we're capturing it for that it turns out we're not using in practice. And we capture this information as well. So I can see on a per label, per dimension basis, uh, how the dimensions that I'm capturing for this metric are being consumed, just like I can for the metric as a whole. And in this case, you can see very clearly one of the dimensions, instance, actually ends up being one of the most expensive in terms of number of unique values, overall cardinality for the metric, is not being used at all. And this is very common, by the way, that we see this in microservice environments when you have a lot of containers running an application and you're capturing metrics from it, but you're not looking at that metric on a per container basis. You're looking at it across the service as a whole. So a lot of our customers in Chronosphere use the other type of shaping that we provide, aggregation rules, to remove the per instance cardinality from their metrics. And that can be very impactful in terms of reducing costs while still giving you the value that you're actually using metric for in practice. And just like
Let's talk a
drop,
little bit more about, oh, sorry, aggregation.
yeah,
Some platforms, other platforms offer aggregation. I think this has been one of the core things that we've really focused on, right? Talk about there's recording rules in Prometheus. We've developed something called roll-up rules, right? And there was a specific reason we did that. And why don't you talk a little bit more about that, just to kind of contrast against recording rules and other types of aggregation that are out there?
sure. With recording rules in particular, what you're doing is you're effectively running a query against data that's already been stored in order to aggregate it. Usually that's being done for optimization purposes, right? I've got an expensive query and I want it to be faster when I load my dashboard. So let's create a rule that runs the query in the background and persists the result directly to the database. That's great to be able to do to make queries faster, but it can be quite expensive because now you're persisting the raw data that you might not even be looking at, as well as the new metric. Uh, it also has some drawbacks to it, such as putting additional load in the system. We have to query the metric, so you're not eliminating the cost of running that expensive query, you're just moving it to the background, right? Which is one of the reasons why scaling Prometheus can be such a challenge, is once you start getting to certain levels of cardinality, you end up having recording rules to go in and make the end user experience more performant, but that doesn't actually reduce the load in the system. It increases it, in fact. The other thing that recording rules can't do super well is handle things like late arriving data. And this is less of an issue with Prometheus itself as it is with, say, the remote storage solutions like Tame or Cortex. But if you have a system that is receiving traffic, and for some reason one of the clients that's sending data to it gets delayed, it took longer to scrape those metrics for one reason or another, or there was a network blip and it took a long time for the data to actually arrive in the system. If a recording rule runs and it persists a result, and then metrics that should have been part of that recording rule result get persisted in the system, there's no way to go and update that data point that was emitted. So when you have late arriving data, you end up with inaccurate aggregated results for your recording rule. With Chronosphere, we want to solve both of these problems. So the aggregation rules that we are applying here, they're done in a streaming fashion. You don't have to persist the raw data in order to aggregate traffic. In fact, you can see here at the bottom, it says, I'm going to drop the raw input data by default. We also are doing this in such a way where if you do see late arriving data, we're able to automatically update the data point that was emitted. So I'm going to go and create this aggregated metric that removes the instance label for my service HP request time MS total metric. If one of the instances that we're scripting this metric from gets collected a little bit later than the others, that's not going to impact the accuracy of my rolled up metric. We are able to update these aggregated data points even several minutes after they've been created. So you're able to get real-time aggregated results that are going to be accurate for your metrics, even when you're doing this. And you can reduce the cost of querying these metrics because we're reducing the cardinality of them, but you're also to reduce the cost of storing the data as a whole, since we're able to get rid of the raw data too.
We find our customers, it's about 60% on average is what they're able to do from a data reduction or volume reduction using this control plane, which I think is an important. It's very. This is how powerful it is, right? It's like it gives you real control over this, a fine-grained control with accuracy, so that you don't have to worry about how you're using these either, right? You can use them in alerts, and there you've got accurate data. Because if a later running data doesn't is giving you inaccurate results, then those alerts aren't worth anything, or the metrics they're using to make those alerts aren't worth anything. So very powerful.
Yeah, and you don't have to choose between accuracy and like recency of the data either. That's other solutions for doing aggregation that try and solve this problem end up waiting longer in order to ensure that you just have all the data before they emit data points, rather than trying to do updates like we do. And yeah, like you mentioned, 60% on average. Some of our customers get even more. A lot of our clients will create, rather than metric specific policies like the one I have here, they'll create broad policies that say, hey, for all of my histogram metrics, I'm going to remove the instance label. And that way, you don't have to go and create this, metric by metric. You can create it for metrics from entire applications or from entire clusters or entire classes of metrics in your system. So it's quite flexible, just like we saw for drop rules, where I can go and do multiple different filters and dimensions that you can match together to get exactly the data that you're interested in. One other thing that's kind of interesting about aggregation rules that I'll show quickly, if I go over to the aggregation rules page, is you can preview what happens when you go and create a rule. So I don't have to go and apply this immediately. I can go and create a rule in the system that is not going to be enforced, but we're going to go and predict what the output of enforcing it will be. So capturing information about how much data is going into the rule and getting matched. How efficient is it? What kind of reduction are we getting in practice by removing the dimensions that we picked? And what is that expected to do for our overall utilization in the system? So that way you can kind of get a feel for what's going to happen before you apply the rule, then go and apply the rule. You can do it in a phased fashion like we showed before with drop rules. And that way you've got the full confidence in the changes that you're making to your workload. Get a chance to validate that they are in fact going to give you the benefits you're looking for.
Not to skip ahead, but I see rule efficiency there. I think we should talk a little bit briefly about that, because I think one of the things, we talk about the operate phase. You could create these rules, but things change in these environments very quickly. And
Yeah.
I think having this insight is very helpful to understanding, is a rule you created still working? Is it doing what it's intended to do, right?
Yeah, absolutely. A lot of the things that we provide the ability to do within Chronosphere, you're going to have metrics to let you know how they're behaving over time. So letting you know our drop rules actually dropping data, our aggregation rules aggregating data as effectively as you want them to. How is that changing over time? Because workloads aren't static, right? They're very dynamic, as we mentioned at the beginning. You can see an example of this here. There was a spike in the rule efficiency for my rule I'm looking at within the last 24 hours. Something happened around that point in time where we were dropping a lot more, aggregating a lot more data because of a shift in the workload. This can be really, really important. One, for helping you get a feel for how effective the decision you've made about your workload is overall, but also as the system is changing, the efficiency of these rules will change as well. And what we see happen actually is a lot of times they'll become more efficient over time, assuming that the metrics that they're matching against are still there as your workload scales because of business scale increasing, right? You'll have more raw data going into the same rules, and they'll get more aggregation by removing dimensions. Again, going back to that example of if we're removing the per container cardinality from a metric, and you have more containers running over time because you're handling more requests as your business grows, that's more raw data getting aggregated down to the same volume of aggregated series. And so the impact of removing instance becomes more effective over time, and you can see slower growth in your overall metric costs than if you had kept all the raw data. So for a lot of our customers, in addition to the kind of upfront impact that they get of doing this analyze and refine steps as they go and operate over time, they are able to find additional improvements, continue to refine their workload, and the initial improvements that they made become, if anything, more impactful.
And predictable, right? That's the big thing, is that a lot of observability costs are very unpredictable. And I think this gives organizations predictability in their use of metrics.
Yeah, absolutely. Having good visibility into the workload itself and how it's changing makes it a lot easier to understand the impact of changes that you're making as engineers and as an organization. And as a result, that visibility gives you better predictability. There's one more thing that we wanted to talk about in our session here today, and that's related to that long-term operation phase. We've mentioned a couple times being able to respond to sudden changes in your workload, right? Those cardinality explosions, where you see a new metric introduced or a new label introduced, and all of a sudden the workload goes haywire. The other use case for being able to get visibility into your workload is around that organic growth that we were just talking about, where it's not a case of we're making changes to the workload. It's a case of our business is growing and the system that we're running is growing, and that causes more metrics. So we've got a lot of visibility into the system to help you understand what your workload looks like over time. The metrics that we have around how the pools that you define for quotas are being used, metrics around things like aggregation, other shaping rules, but also metrics about your metrics. So one example of that is this metric growth dashboard that you can see here. What it will let me do is take a look at all of my metrics by name and how many data points per second we're seeing over time, where all the dimensions that I see for those metrics and how many data points per second we see associated with those dimensions over time. This is very helpful for being able to understand what kind of growth we're seeing in our workload that might be happening organically or because of those dynamic shifts in your infrastructure throughout the day. If you have a spike every single day at 12 o'clock, you can go and use this dashboard to understand, what is happening between 12 o'clock and the hour before. What is changing the most hour over hour in terms of my metrics or my dimensions? Can you help me isolate where that's coming from? You don't have to be in the metrics analyzer looking at it when it happens. We can go back and look at it retroactively, both in terms of data points per second, as well as in terms of the cardinality of individual metrics, how many series we actually saw over time. So being able to do this for any historical time period can be very helpful for being able to get a feel for trends in your workload, or when there are spikes, we can go back and analyze them after the fact, as well as being able to do it in the moment like we showed before.
Excellent. All right. I think that about wraps it up, right?
I believe we covered everything we set out to. Are there any other points that I missed discussing, Scott?
I don't think so. And I think we're coming up against time here. So, this was a very quick overview of the control plane. Obviously, it's all about controlling metric growth, which is about controlling metric cost. If you're keeping count of the number of times you said control, you can just add 3 more to that. I didn't actually keep count. I don't know if you did, John. Maybe you did, maybe you didn't. But if this is, if you're if this is interesting to you, again, this is a very high level overview. I would love to have a deeper discussion with you. And there's a lot of resources on our website that you can go and, look at and do research on to understand more about this. As I said, you're going to get a link to that blog post about the OllyDoc, the observability data optimization cycle. And you can dig into that, but feel free to reach out to us. We'd be happy to talk to you more about this and show you how this can actually work for you. So with that, thank you very much for attending. And I hope you counted the number of control and you win that Control Freak kit. Thank you. Thanks, John.